So let us reorient ourselves. You started out with a whirlwind, very simple example tour of kind of a very trivial Rails application. Then you learned just enough about the language to confuse you slightly more. And now we are going to jump back into Rails and ideally use some of the language stuff that you just heard about and show how it's used to implement features of the framework. So we're obviously collapsing this together with the lunch break. All right. Yeah, most people seem to be here. And those who aren't here are probably quick enough to catch up. OK, so here is what happened. This is what the content for this next chunk is going to be. So we talked about the fact that a Rails application is really just a way of instantiating the model view controller design pattern. And correspondingly, there's sort of three major chunks that Rails is composed of that give you each of those three things. So we're going to go into some small amount of depth on each one of them. ActiveRecord, which is the model part of MVC. So we'll talk about record accessors and attributes, constructors. We'll talk about finding things in the database without ever using SQL, about validating invariants on record attributes, and a whole bunch of other good stuff. And then after lunch, when Will comes back on stage, you get to the real good stuff in ActiveRecord, which is how it helps you manage collections of objects where objects have relationships to each other. Then we'll talk about ActionView, which is the view part of model view controller. RHTML is the way of templating Ruby code into HTML templates. You've already seen that. There's also a few other ways of doing templates that we'll mention. We'll look more at forms and the way that forms interact with model objects that come out of your database and the ways that Rails makes it easy to link those things together, so linking together the view with the model. And we'll give a kind of a preview, if we have some time, of how those, all of that stuff, how we're going to use that sometime after lunch to Ajaxify our applications and make them all cool and Web 2.0-like. And then finally, we'll look at ActionController, which is the collection of stuff that lets you implement the controller part of MVC. In particular, how do the controller and the view interact with each other? Because we've seen there's sort of a two-way interaction, right? The controller responds to a user action after the dispatch, but the controller also then falls through to a view to render something about the model. So we'll look at what facilities are used along each of those arcs. We'll talk about how sessions are managed. So we mentioned that HTTP is totally stateless, and every request is in principle independent at the transport level. But of course, at the level of the application, you want to give the user the illusion of a continuous session. So we'll look at how that's enabled. And then stupid tricks that you can do with filters. And don't worry about what filters are. We'll get to it shortly. So here we go with ActiveRecord. Let me do a quick review. This is something that I think Will didn't quite cover in much depth. And so that you don't get confused when you see the notation, let me do a very quick review of hashes in the Ruby language and function call notation. So like most modern scripting languages, Ruby has associative arrays. Perhaps less like most modern scripting languages, any object can be a key, and any object can be a value. And in fact, they don't all have to be of the same type. So here's a simple example of declaring an immediate value for a hash. The keys in the hash are foo, the symbol foo, the one-character string x, and the integer 3. And the corresponding values that those keys index are the integer 1, the language primitive value nil, and an array containing the single-character string a and the integer 4. Big deal. If I try to dereference a non-existent key, I will get back nil rather than exception. But an interesting notational thing is that in many cases, for function calls, you'll find that the parentheses are syntactically allowed to be omitted if it doesn't cause an ambiguity in parsing, which is a nice way of saying an ambiguity in parsing from its point of view, not yours. You may think that you knew what you were going to parse, and you'll be unpleasantly surprised. But that's why, especially when we look at a lot of the Rails code or Ruby code that is embedded in things like Rails templates, you'll see stuff like this on the right side, where I'm calling this function foo with 2 arguments, and I'm omitting the parentheses because the context in which I'm calling it makes it unambiguous that this is the beginning and end of the argument list. Right? But the form on the left with parentheses is the sort of canonical form, and that would also be allowed. To confuse you further, if a function takes an argument which is a hash, and your intention is to pass an immediate hash to the function, as in this case down here, I'm calling function foo with this hash of 2 keys, it's legal to omit the braces from the hash if it would be unambiguous as well. So these 2 calls are syntactically equivalent. And in fact, if I omitted the parentheses from the right-hand side, that would also be legal. As usual, caveat programmer, commas are evil. And there are many, many cases in which, basically, if the syntax is anything less than 100% obvious to any fool, don't do this. But as it turns out, there are a lot of cases in Rails where the syntax is 100% obvious to all fools. And so you'll see a lot of examples of this as we go through this next chunk. It may occur to you that this is kind of an easy way to do keyword arguments, Lisp-style keyword arguments. In particular, if I just declare my function to take a single argument, which is a hash, I can search that hash for keys that match the keyword arguments that I'm willing to accept. I can default the ones that I don't, et cetera. So there is a default argument convention built into the language. But the way that you'll see these used in a lot of Rails examples, they're basically serving the moral role of keyword arguments. One caveat that might have already occurred to you if you're drinking a caffeinated beverage with your lunch, which I heartily encourage, is that if you have a function that can take multiple arguments, each of which is a hash, then it becomes confusing because it's not clear which key value pairs associate with which hash. Right? And in that case, the right answer is to explicitly surround each hash with braces and surround the argument list with parens if you're not sure. OK, onward. Any questions about that? Is that either clear to everybody or you don't care about it? Good. OK, so let's start out with ActiveRecord. What is ActiveRecord? To a zeroth order, and again, people who know the language and the framework in more depth, I'm going to make a lot of statements that are simplifications of reality, and I will disclaim them as such. To a zeroth order, it's a class library that provides a very nice object relational model over a plain old relational database system. I say plain old in a way that glibly sweeps aside the decades of development that have gone into making them so useful that it's now just assumed that they're going to be part of your web application. But I can be forgiven for that. Basically, ActiveRecord allows you to deal with collections of objects with attributes and with relationships among those objects rather than dealing with the way that the underlying objects are stored in a database table. So rather than talking about a collection of rows of a table, I talk about a collection that is enumerable in the Ruby sense. And remember what enumerable means. It doesn't mean that it is an array. It means that it responds to the each method, which means that I can successfully call each and get elements out of it. Don't worry about whether it's an array or what class it is or anything. It's an enumerable, and that's all that matters. So if I do a query and I get back a collection of rows from a table, I can treat that collection as an enumerable collection rather than walking through it some other way. For those of you who are familiar with more advanced SQL programming, a very common idiom in SQL is to have a foreign key relationship between one table and another. And in fact, what you typically use that for is, for example, I could say that any advised, I have a table of professors, a table of students. Any professor has multiple students who are advised by her or him. And in SQL land, what that means is I would look in the students table for all students that have a foreign key field matching the ID of a particular professor. But in real life, what I'm establishing is a hierarchy, right? I'm really saying a professor has many students. And any given student, quote unquote, belongs to a certain professor. What we'll see when Will talks about dealing with multiple models is that at the Ruby programming language level, you can actually talk about that hierarchy in intuitive terms, right? You can take a professor object, which came out of the database. You can dereference the student's object, which isn't a real object, but will become a collection of rows that came out of the right table, and the foreign key join has already been done for you. And in fact, you can go the other way. Given a student object, you can dereference student.professor, and that translates into the right query to figure out which professor corresponds to that student's foreign key. So to a zeroth order, if you don't know or care about SQL joins, great, because you won't have to. The queries get generated for you, and in most cases, they're about the same thing as you would have written if you had handwritten the query out yourself. So let's go back into real life here and look at the student example. One of the things that Will touched on was this idea of attributes and attribute accessors and stuff like that. If you remember, and you probably don't, so let's go back to Emacs and take a look at my student model. Whoops, I probably mistyped it. There we go. So there's the student model. That one, I just cleaned out all the code, so it doesn't do much. Students controller, that's probably what I wanted. Oh, I switched it back to scaffolding. All right, well, that's what you get. Hold on. This is how you do version control when you're trying to get demos to work during a class. OK, that's not how you do it. Don't worry about it. If I could magically pull up the buffers that we were seeing before, oh, wait, I can do this. We can find them in the views instead. All right, we could find them in the old version of the views. Don't worry about it. What we had been doing in the views, we had been dereferencing attributes like student.graduation date or student.UCB SID which looks superficially like a instance, or bleh. It looks superficially like an object that is an instance of a class dot an instance variable of the object. But as Will pointed out, instance variables aren't really what we're getting in the traditional sense because the instance variables aren't visible outside of the object's class. And in fact, what we're doing is we're calling a function that returns the instance variable. So if you look at the code that's kind of pasted down the right-hand side here, I've shown two essentially equivalent ways of defining a class that has bar as its only attribute. This is the first sort of longhand way. I'm declaring my class foo. My initialize function is going to take a hash, which if is not passed or by default I'll take to be the empty hash. It will look in that hash for an element whose key is the symbol bar and assign it to the instance variable bar. So that's the one and only instance variable in my class. And now, if this were the C++ or Java world, I would usually define an accessor, also called a getter, and a mutator, also called a setter. So here they are. Bar is a getter that just returns the value of the instance variable bar. Setter takes a new value and assigns bar to that. And by the way, notice this. What's actually happening here is I am overriding I'm declaring a class method called bar equals. In other words, I can individually override the assignment operator for pretty much any class attribute. This will turn out to be extremely useful, as you'll see. Down here is a much more compact way to do the same thing. In my class autofoo, I just say attribute accessor : bar. And using metaprogramming, essentially this stuff up here is generated for you. It's not exactly that, but it's close. Right? So again, remember, as Will pointed out, attribute accessor is not a language keyword or anything like that. It is just a method call. Right? That's why metaprogramming rocks. This is used all over the place in Rails. But in fact, in the common case, you don't even have to say attribute accessor. For example, going back to my student model definition, you'll notice that there are no calls to attribute accessor in here. Why not? Anybody? Bueller? OK, let's go back. It's important that you guys follow along with me. So no, but you're heading in the right direction. I said that ActiveRecord is a layer over a relational. Come on, guys. It's a layer over the database, right? So in fact, if I go to my database, student.rb, well, convention over configuration says that if the model name is student, the database table is students. Sure enough, there it is. If I look at the database table, I mean, I don't have to declare attribute accessor because the database is telling me what the attributes are. Right? The reason I don't have to say anything in here is because the attributes come from the database. My declaration of the model as inheriting from ActiveRecord base says that by default, you're going to get an initial set of attributes that are whatever the table columns for that model are in the database. And by default, those attributes will allow assignment and dereferencing. In fact, we can go one better than that. You'll notice that in my controller, I have gone back and changed it to the old style of scaffold. So I deleted all the views and all the crap code, and we're just going to go back to default scaffolding. We will verify that that still works. So new is actually now synthesizing on the fly the new controller method as well as the new.rhtml view for me. But now let us go back to the database and add a field to students. Let's call it first name, and we will make it a string. There. I will now reload the page, and lo and behold, the first name attribute now exists, right? Again, I didn't specify attribute accessor, but because the way the model is constructed is by looking at the underlying database, and in fact, I'll go you one better. If I reorder the fields in the database and reload, because the scaffolding is, I'm using the default scaffolding that doesn't do anything clever, so I'll get the field names in the same order they came out. Right? So that's, I mean, if that's not easy evolution of your schema, I don't know what is. But back to reality here. So now you know about attribute accessor. As it turns out, there are other reasons that you'll want to use attribute accessor, and here's why. In my student example, I didn't actually have to declare any attributes because I'm just using what's in the database. But by using attribute accessor, I can do other cool things as well. For example, if I can find it. Here we go. Let me copy and paste some code here. Automatic. By the way, if you're not sure what's a language keyword versus what's a function call, use Emacs. The Ruby mode highlights everything in nice colors so you can tell. Right? Things that are in purple are actually language keywords or reserved words, and things that are in black are not. OK. Yeah. It's like VI, only not obsolete yet. OK. So I'll save my students controller. So what have I done here? I've actually added the equivalent of 2 virtual attributes to the student. Actually, I've added 1 predicate and 1 virtual attribute. The predicate is youngster, which is someone who is graduating, if you're graduating any later than about this time next year, that makes you a youngster. And I've also added this synthesized attribute called days till graduation as string. And you can see it's pretty obvious how it's computed. I'm first dereferencing degree expected, and that's a normal database field, right? We saw it. I'm getting today's date from the built-in class date. And if the graduation date in the database has not been initialized, then I'll print out this person will never graduate. Otherwise, I will print out either how many days ago or in how many days the person will graduate. And notice that, yes, indeed, these are both date objects. You can subtract them. The right thing happens. Why is that? Is it that minus is really smart? No, minus is a class method like everything else, right? Equality, assignment, the 3 equal sign operator, plus, all of those things are class methods. So date happens to define minus in a way that makes it do what you would expect. OK, so let's take a look at that. How can we tell that? Let's actually go and modify the list method. In fact, let me go back and rescaffold the student so that we can do that easily. This will take just a moment. In the meanwhile, you can read this lovely code. OK. Let's go back, and in the controller, we now have oh, whoops, I put these methods in the wrong place, didn't I? These are supposed to go in the model. Student.rb. There we go. That's where I needed to put those methods. And I will grab the, OK, so I've rescaffolded the controller. You've seen all of this before. In fact, I've rescaffolded the views as well. So now let's go to the student list view, and I'm going to add a table. If you remember what this view looks like, if I list the small number of students, oh, we don't have any. Let's add one. I'm going to add myself. Good enough. In fact, I will add one more. All right. That's plenty to work on. So you can see that the list template just shows us this really simple no-frills table with all the database fields in it. Let us go actually change this template and add a table with our new virtual attribute. We're not going to link to anything here. And now I need to explain the view, but bear with me for just 1 second. So I'm adding a table heading, and now I'm going to add what did I call that method again? Days till graduation is string. Lovely. And hopefully I spelled all of that right. Good. Now we will reload the list. OK, the formatting leaves a little bit to be desired. Oops, it's because I forgot to close the table cell. What did I? Oh, whoops. Thanks. That was supposed to be a quiz. Yes, I forgot to actually say, oh, by the way, this is code, not HTML markup. You know, it still doesn't look very good. Did I? Oh, you need to put it above the links. No, I'm. Well, you don't need to. Yeah. Oh, duh. I hate that. OK, hold on. We can do this. This is what happens when you don't test out a demo in advance. This goes up here. And I'll explain it in a second. And this really should go like there. OK, I bet my salary this time. Not that it would have been a huge loss. OK, so what happened here? I added a table column with this heading graduation when. I added a table column in the body that actually prints out this message, which is just a call to that virtual student attribute. And this is actually a good chance to walk through a little bit of what's going on in this code. So a few things are happening here. And remember, this is just the default generated scaffolding. I haven't really touched this except to add that column that I just added. So let's take a look at a little bit of what's going on. And I don't know if I should use a laser pointer, but the hell with it. So what's going on up here, we have some embedded code that says for column in student.content columns. Content columns is a class method of student. It's really a class method of ActiveRecord base, which student inherits from. And it basically enumerates what columns in the database are the attributes of a student. The fact that it's called content underscore columns means that it automatically knows to omit things like ID, which, as you remember, is the primary key in the database, but it isn't a real attribute of a student. So for each one of those columns, it's going to call the human name function of the column. What does human name do? Well, note that here I have a capitalized first word, lowercase second word. If you look at the actual database schema, everything's lowercase with underscores, right? Again, convention over configuration. There's a set of conventions for converting words that are capitalized that way to words that are capitalized this way, as in the table header. So that's what human name does. That's simple enough. And then we actually get to the body of the table. Now, where does this variable at students come from, which we haven't seen yet? Well, if we look at the controller and we go to the list action, we see this statement. So we're assigning student pages and students to this cool method call called paginate, which don't worry about it for now. But basically, it's going to look up this table in the database and return chunks of it as pages with n rows listed at a time. So, but the important thing is that the instance variables are being set up in the controller method, right? Any instance variables that are in my controller method are going to be visible to the view once I fall through to it. And remember, as Will said, that the @ sign tells you that it's an instance variable. By the way, it's an instance variable of what? This is a subtle point, but worth keeping in mind. It's an instance variable of the controller, right? Because if you look at the class header, this entire file declares a class called studentsController, which inherits from ActionController. And then I declare a bunch of methods that are particular to this instance. So it's roughly speaking, what happens is every time you make a new request to the server, each new request will instantiate a new object of type studentsController. And these are instance variables of that object. Once this HTTP request finishes and the result has gotten sent back to you, they are destroyed, as is the instance object that, well, it's not destroyed. It'll be garbage collected eventually. But that's what these are. So once the list controller method has set these up, I can go back into the view. And the paginate method works in such a way that students is going to be set to be a collection of rows from the database that match whatever the criterion was for search. We'll get to searching in a moment, but right now the criterion was just return everything. So effectively, students is a list of all of the database rows from that column, from that table. And I'm just going to iterate through setting student to each one at a time. And I'm going to dereference. There's the column names. This is all the header stuff. And if I scroll down, so what's happening with student.send column name? Again, you have to think Ruby a little bit. Student is an instance of a student object. And I am sending it a message to say, call your method whose name is the name of this column. OK, a little bit confusing. Let's go back to the videotape, as we say. Column.name, well, here's the database. And here's the names of the columns. There's one called last name underscore first name, et cetera. Here, I'm taking a student object. And in turn, I'm sending it the message last name, the message first name. And in turn, because ActiveRecord defines those methods for me using the moral equivalent of attribute accessor, those methods are defined to grab the underlying values from the student object. Did that make sense to everybody? This is fundamental, right? Like it's all downhill from here if you got that much of it. So this is a good time to ask for clarification. Yeah. Oh, I'm sorry. Good point. So another way to parse this might be that. H is actually a method provided by Rails that sanitizes the contents and makes it HTML safe. That's all it is. But Marty had the real question, which is, what is send? So remember that in Rails, everything is an object, right? Send sends a message to the object asking it to execute one of its methods. So in this case, I'm sending a message to it saying, in turn, execute each of the methods identified by the names of the columns. So it's pretty neat. It's a little, there's a, you fall down in an endless array of mirrors if you don't see this. But, and keep in mind that if you were to writing your own views, this is a shortcut because it allowed, remember before when I just added a field to the database table and then I reloaded the view and automatically a field corresponding to that new attribute was appearing in the edit view? That's what lets this happen, right? This view does not enumerate all of the attributes of student and print them out one by one. It actually just has a for loop that says, grab the names of all the columns out of the database, and for each column, send the object a message asking it to run that class method, or to run that instance method on itself. OK, so that's pretty neat. Let's go back to, here's another cool example of what you can do with these virtual attributes, right? So virtual attributes, the way that I'm using the term sort of loosely, is an attribute that doesn't directly correspond to an underlying database column, but is actually some code that you've put into your model. This is a simplified excerpt from a real application that I have that's running someplace. So I've stripped out a lot of ugliness to make it easy to understand. But the goal here was to have a way to accept and store and authenticate customers logging into my application using a password. But I didn't want to have to store a clear text version of the password. On the other hand, I don't want to have code all over the place that deals with the fact that the password isn't stored in clear text. So the Ruby way that you do this is you encapsulate this stuff in the model, right? And the way that you do it is by overloading the assignment operator. So what happens here? If I have a customer object and I say customer.password equals whatever, what really happens is the password equals method is getting called, right? So remember, assignment is not a language primitive. Assignment is a class method, and you can override it. So I've defined a function that takes a single argument, which is the password. I strip the spaces off of it. I apply some salt. And then in my customer object that was originally passed in, I create a hashed password field. And this really is a database attribute in my application. So if you look at the database schema for a customer, it doesn't have a field called password, but it does have one called hashed password. So I'm going to assign hashed password to be basically a SHA-1 digest of the salt plus the supplied password. Now, from the point of view of the application, in the mainline logic, all I said is self.password equals whatever. And by overloading the assignment operator in my class, the right thing happens. Similarly, I can call a method where I want to, I have a customer object, and I have a password that's been supplied on a form, and I want to know if the password matches the username of that customer. So I define a model function called authenticate that takes the username, takes the password. These were both typed in by somebody on a web form. We'll see in a minute exactly how find works, but basically, I find the first record for which it's the case that the username matches the thing I was given. And if I find that record, in other words, if that's non-nil, and if I can encrypt the password I was given with the salt and have it match the hash password in the database, then goodness, right? That means that the password supplied when hashed with the salt validates the customer. Great. And notice that this is just a conjunction of terms. So this will either evaluate to true or false. So customer authenticate is a simple function that just returns true or false based on this. The password is not stored anywhere, but the implementation of how the password's stored or how the authentication happens is outside of the application code. Very cool. So would that be a question mark? You could do that. Probably. Good catch. If my coding habits were a little bit better, it would probably be something like self dot, password matches question mark or something like that, because it does return a Boolean. Good point. Yes?
So here the password in some sense is stored in the running application. So if like your database crashed or something and the person wants to come back later and you have to find the password.
It's in your database. I mean, the answer to that is back up your database?
Well, I'm not sure I understand the question.
Here it's like it seems that the important part is the salt, which does the encryption. And salt.
Oh, I'm sorry. The salt is actually stored in the database too. If you could see my underlying schema, the customer table in the database has an attribute, a column for salt and a column for hash password. Right? But this is a case in which I actually am not exposing the exact underlying schema up through ActiveRecord to the application, right? Password is this kind of fake attribute. And by the way, notice that password is a write-only attribute. There's no method called password. There's only a method called password equals. So if I try to dereference self.password on the right-hand side of an assignment, it won't work. I'll actually get an exception that says there isn't a method that will do this. Right? The methods are separate. OK. Any other questions on this?
Let's look at the beginner question.
Absolutely not.
Why is it self.start.salt instead of @salt?
Why is it self.salt instead of @salt? Because I actually want to. So this is a case where I want to use the underlying ActiveRecord libraries, basically, what I want is the value of salt. Ugh. I want the writer for salt that is declared for me through ActiveRecord. In other words, I'm not trying to.
The problem is if you just had salt
way.
as a bear word, it would think you're trying to assign. Okay, but if you try to just say salt equals that thing, it would assume it was a local variable assignment. You did @salt. The ActiveRecord variables are not stored as instance variables. They're actually stored in a different structure. So this actually is calling a method called salt equals on your current object.
Let me expand on the answer to that, because Keith's question is a really good one. Why am I assigning to self.salt as opposed to assigning to @salt? I mean, if salt is an instance variable of class customer, shouldn't that work just as well? And the answer is, actually, salt is not an instance variable of class customer. Salt is a column in the database for which ActiveRecord provides an accessor called salt. Right? This is why when Will was talking about there are really no instance variables, everything is a method. Right? Self.salt is not a variable, it's a method call. If there were an @salt that was an instance variable of customer, it actually would be visible here, but it doesn't have the semantics I want, because then it would just be a variable. Right? This method call actually results in modifying the underlying database object.
Which is that it isn't a salt method, it's a salt equals method.
Yeah, well, it's a method.
This call, yes. So this call is implicitly calling salt equals. So let me maybe this will help. If I were to write, I know, but for the benefit of the other 59 people, this might clarify somewhat. I could write that, right? Or I could also write. Yeah. All right. Well, I'll skip it after all. But I think if your question got answered, then I'll go on. But it was a very good question, because it actually illustrates very well why it's important to keep in mind the difference between actual instance variables and accessors on the instance variables.
I can mention a little bit more of that in depth when we go into ActiveRecord.
I guess what I should have said is that somewhere inside ActiveRecord, the moral equivalent of the following is occurring.
Right.
Yeah.
Right? And essentially, when I say self.salt equals something, that's syntactic sugar for calling the salt equals function with the argument that's on the right side of that. OK, good. OK, so with all of that under our belt, so to speak, how do we actually go about creating new object instances for these ActiveRecord model objects? There's at least 3 ways to do it that I know about, and probably there's a whole bunch more. One of the ActiveRecord provided constructor actually allows me to call it in a couple of different ways. One way is that I can call it with essentially a hash of the attributes of the new object that I want to create. So these elements that I'm specifying as symbols are expected to correspond to underlying database attributes. If I don't specify some attributes, for example, in this case, I didn't specify graduation date, then it'll take on whatever the table column's default value is declared to be in the database. When you set up a table in a database, you're allowed to declare for each attribute what default value it should take if an instance is created without specifying that value. And I don't remember, I think I said null for graduation date. So this is one way to do it. And by the way, this is an example of the calling syntax where effectively I'm passing new a hash, but I'm omitting the braces around the hash because it's unambiguous. Another thing I can do is I can say student.new and then open a closure. Right? So basically what's going to happen is that this newly created student object is now going to be bound to the local variable stu in the body of this closure, which means that now I can do these assignments. And this has the same semantics as before, where I'm actually calling setter methods on them. How is it that I can call the same method new either way? As Will briefly mentioned, there's a built-in predicate called blockGiven, which allows the new function to determine whether you have tried to pass it a block or not. So it can actually behave differently. It's the moral equivalent of polymorphism. And then, of course, the third way is I can just create a new object with no default attributes, but then I can go in and selectively override the ones I care about. So 3 easy ways to create an object. However, all I've done is call new. I haven't called create. This is important, right? Because new just means I've created an object that's ephemeral. What I really want is to be creating a new record in my database. And those 2 operations are different in Rails. The create operation is actually the one that causes the record to be written via SQL insert call or whatever is necessary. So there's a couple of things that I can do for that. S is still my student object that I just created. I can call the save method, which again is provided by ActiveRecord base, and that will write the object out to the database. I can also do a single step, basically a shortcut. If I say s.create and I pass a hash of arguments for the different attribute values, that's roughly the same as calling s.new and then filling in the argument values for that and then s.save. I can also, if s is an existing object that's already in my database, I can say update attributes, and I can pass a hash whose keys are the specific attributes I want to update. The ones that are not mentioned are left as they are. And if somewhere in my code it actually matters for me to check whether s is a brand new record that has never been written to the database versus s is a record that was retrieved from the database and I'm about to modify it, I can actually call new record, question mark, which will give me the answer to that. And as I'll show you, there are cases like filters where this actually matters. When you call save, it does the right thing. What do I mean by that? It means that if s has never been put into a database table before, it will do a SQL insert. If s already exists and you're just changing some attributes about it, it will do a SQL update, and you don't generally have to worry which is which. Again, the convention over configuration comes back. I mentioned that unless you specify otherwise, tables that represent ActiveRecord models are created along with a column called ID, which is assumed to be the primary key. And by the way, the other reason you want to do this, and I realized in my example from part 1 that something was broken. I used to have, this column used to be called UCB_ID. I've now changed it to UCB_SID. Why have I done that? Because I forgot that if you have an attribute called something_ID, it's assumed to be a foreign key to the table of somethings. So UCB_ID, by convention, is assumed to be a foreign key to a table called UCBs. And I didn't have any such table. And it's because I screwed up and it was like 3 in the morning. OK. Yes?
So on save, right, will it let you know whether it did insert or update when it returned?
The save method itself, I think, won't. But I think you can query the object to figure it out.
There's actually two
methods,
save and save bang. Save will return whether it's saved correctly as a true/false. Save bang will tell you, will throw an exception if it doesn't save.
Yeah, but I think his question is, assuming it succeeds, how do you know whether it did an insert or an update?
Oh.
Right. The way I would do it is before calling it, I would call new record.
Yeah.
Because if new record is true, then it's going to try to do an insert. And if new record is false, it's going to try to do an update. And for all I know, there's probably another way to do it as well. ActiveRecord has a lot of stuff in it. OK, another cool convention over configuration. If your table has a field called updated at, or a field called created at, then every time the object is touched, that field will be automatically updated with a timestamp for you without you having to do anything. In fact, if the field is called updated on or created on, the timestamp will have the resolution of time as opposed to the resolution of date. So a bunch of other nifty free features that you get if you and all you have to do is make sure that this attribute's present. In fact, just for our amusement, we will add one, and then later on we can query it. It's a date time, right? All right. Well, you know what? Just to be safe, we'll add both. Exactly one of them will work. Notice also, by the way, that if I now reload this listing of students, I get updated on and updated at as well, which I didn't necessarily want. But if you remember, the way this is generated is that content columns is called. Guess what? I can override content columns to say, by the way, when you're extracting the content columns, throw out the following ones that I don't want you to see. And in my example with the hash password, that's exactly what I do. I actually override content columns so that hash password never shows up, because why is it useful? OK, moving right along. But what can go wrong if you try to save a model object? A common programming pattern, I guess, is you would like to make sure at the time that you create a new database object or update the attributes of one that certain conditions over the fields in the schema hold. For example, let's go back to the case of student. I might want to make sure that when a student is created or updated, a degree expected date is actually specified, which is why I've said in my example here, validates presence of. And again, remember, these validates whatever, those are not language primitives. They're not even macros. They're just method calls. They're provided by ActiveRecord. I might want to say that, of course, it's going to be UCB_SID now, but I might want to say that that has to be a number. Remember that when we're typing in this stuff over these web forms, you're just sending a bunch of strings to the server. And there's nothing to stop you from sending a non-numeric string for UCB_student ID, which would cause grief if you then tried to store it in a database field declared to be an int. So I might want to say validates numericality of, what a graceful name that is, the attribute called UCB_ID. In fact, I might want to go further and say that its length has to be somewhere between 7 and 10 characters and specify this message, which I'm going to show you where and when you would see it if that isn't the case. I could also be more sophisticated and say UCB_ID has a special format. So I'm just going to give you a regular expression, and it has to match that. And otherwise, I'm going to issue some other message. Validates uniqueness of. For example, perhaps there can only be one student with a given UCB ID number at any given time. Validates uniqueness of will actually catch that condition. And in fact, I can go further and say last names also have to be unique, but only within the scope of degree expected. In other words, I can't have two people who have the same last name and are graduating on the same date. But if they have the same last name and are graduating on different dates, then that's OK. Right? This is pretty cool. So one thing you should notice right away is this is the kind of stuff that normally you would have to put into the part of your code where records are being updated or created. This is all declarative. This is all still in the model file. And we've just written down essentially a set of declarations about what must be true at the time that we do an update on a model object. So in fact, what will happen, shall we try putting one of these in and violating it? Let's do that. Let's go to our student.rb model. And let's try validates presence of degree expected. And well, that's a problem. That's flip. No. All right, let's give it a shot. I'm now going to create a new student. Degree expected is a bad one because it's provided by pop-up menus. Let's try. OK, so now I'm going to type in another student's name, but no student ID number. Pretty good. One error prohibited the student. Look at all this like great fancy formatting. Have I written a line of formatting code? I have not. So I get the helpful error message back that I had specified in my validation. I also helpfully get the field outlined in red showing where the error was. Pretty good for no code. In a minute, we're going to walk through exactly how this happened. But first, Larry.
So in the database world, people tried to move validation checks like this to the point of when you exited the field, as you were typing in across the field, so that you wouldn't necessarily fill in the entire form, say insert, and then get back a blizzard of validation checks. There's some mechanism to do that.
So let me restate the question that I think you're asking. It would have been great if at the time that I tried to either click create here, maybe even as I was traversing the fields in my input form, that I would have gotten a warning about that rather than having to wait a round trip to the server to say boink. The answer is yes. There are multiple ways to do it. Probably the way it's most often done now is with Ajax, and we'll show how some of this Ajax-y stuff fits in. The nice thing about Ajax is that once you understand the basics of MVC and Rails, Ajax is literally like a one-line change. And intellectually, it's like even less than a one-line change. All of the machinery gets reused. So great question, and the answer is it's coming. OK, so what actually happened here? Oh, sorry. So here's my. So what actually happened here? Let's look at first of all, what's the more general version of validations? Whenever you are manipulating an active record model, there's various well-defined points in the lifetime of that model when you have the opportunity to do something, to do a validation check or to write an audit record somewhere else or whatever you want. Without going into great detail on the slide, you can roughly see that when you save a model, and by the way, these two flows for new record and existing record, they're almost identical except for the fact that the callbacks have different names. You're allowed to specify callbacks for any or all of these. So before the validation checks are run, before the validation, but after validation, before the create, after validation on create, and then now the validations have succeeded, but the object has not actually been created. So you can specify code to be run at any one of these points. And with that perspective, it should be clear that validation is really just one special case of a callback that occurs during the model lifecycle. So what actually happened? Let me see where this is. OK. So let's walk through what actually happened in the validation here. How did this stuff all come together? Because I don't think that I have. Okay. I'm going to defer it till forward. I was going to walk through what was the magic that allowed all of this to happen without me having written one line of code. But it'll be easier to walk through that magic after we've done a little bit on view and controller. So for the moment, just remember that magic occurred. I specified declaratively a condition on my model. And lo and behold, when I tried to create an instance that violated that invariant, I got this great new, I got this error message framed with a red border and highlighting of what I did wrong. We're going to come back to this to understand how it worked. But you're going to have to bear with me for one moment. In the interest of time, I'm going to skip that because it's similar to one we already did. Let's move on for the moment to find. A great many things in your ActiveRecord related code are going to end up using this method. And find is, again, to a 0th order, it is the ActiveRecord layer over SQL select. It's actually a good deal more than that, but let's start from that. And again, this is a method that's provided by ActiveRecord. So any class you define, like student, which inherits from ActiveRecord, will inherit this method call. Here's a simple case. Find the first student. Okay, in this case, first means whatever the database decides to return if I say limit 1, and who knows what that'll be. I can also say student find :all, which means return all students in the students table, irrespective of any particular conditions. And this is going to return a what? Anybody? Here's a hint. It's not an array necessarily. It's an enumerable, right? It doesn't matter what it is, but you can call each on it, and you can call all of the other methods that assume that each exists. And we'll come back to that in just a moment. We can do a find by ID, which is the primary key. You don't usually want to do this, because if I say find something whose primary key ID is this, remember that the primary key is not a real attribute. It's a housekeeping attribute that I'm providing for the database's benefit as an index. So if I do this call, I'm really expecting that that primary key is going to exist. And in fact, that method will throw an exception if it doesn't exist. So this is rarely the thing that you want. But in fact, I could do a more sophisticated version of that. Is if I have a function that returns a long list of student IDs, and I have of primary key IDs from the database, as long as I have reason to believe that they exist, I can actually pass that whole array, and I will get back an enumerable consisting of all the rows that respectively match each one of those primary keys. More useful are things like this. I can do a find by column values. I can say student.find by last name. Notice I've put by last name in red. Why is that? Because it just so happens, and it should not strike you as coincidence, that last_name is one of the field names in my database. Will briefly talked about this cool method missing. Basically, what's happening here is that when I call this method, find by last name is lazily created at the time that I do the method call, based on the fact that this attribute can indeed be found in the database, and it's possible to then conjure up a select that uses this as the column constraint and this as the column value.
So they dynamically parse. They parse the method name.
Right. So basically, find by underscore a bunch of stuff. This is what's going to get parsed to understand whether it's possible to synthesize a method that will do the right select. John?
That's cute, but why is that any better than just saying student find by field name, where you give the field name as one argument and the value is another one?
Syntactic sugar, if you want to think about. Yeah, I mean, sometimes one is more readable than the other. And in fact, in a minute, I'll show the canonical form where you can specify your arbitrary conditions. The other nice thing about this, and this is subtle, but when you specify, when we get to doing a find based on arbitrary conditions, the arbitrary conditions allow you to use a bunch of keywords that are essentially SQL specific. ActiveRecord is not a perfectly, it does not abstract SQL 100% away. Arguably, that might have been its design goal, but SQL leaks back in from time to time. So for example, if you wanted to implement this over, say, Berkeley DB, for which there is in fact an adapter, this method is completely database agnostic because the implementation of it is hidden. But if I say find by conditions, and the conditions contain some SQL keywords, a non-SQL understanding database will choke when it gets to that. Now, for most applications, it's probably not a big deal because substantially everyone who uses a database uses one that understands a reasonably recent version of SQL. But that's one reason why you might use this. In practice, it probably doesn't matter. Sometimes this is easier to read, and sometimes the canonical form is easier to read.
Is that how you can do sorting? If you have the index and can sort of an index, do by last name, and then pass it a parameter for all, would return all your values sorted by the last name?
No, it would return all your values in an arbitrary order, which probably would correspond to the order of primary keys, which has now we'll get to sorting in just a second. And roughly, this is another place where the ActiveRecord abstraction leaks a little bit because in principle, there's at least two ways to get a sorted collection. One of them is to get a collection in arbitrary order and sort it yourself. Another one is to know that SQL happens to support a keyword called order by, which allows the database to do the sorting before it hands it back to you. And usually that turns out to be the more efficient way to do it.
That's what I was wondering if that find by last name is doing.
Ah, I see. So no, do not confuse this by with the by that is associated with sorting. This just means find. Maybe it would be clear if it was called find according to last name, but it's not. It's called find by. Huh?
It's a lot of typing.
Yeah, that would be a lot longer to type. And again, in the sorry, another question.
Yeah, I was just going to ask, in the find by last name, can you pass a list of or an array of last names?
I think the answer is that yes, you can, and the right thing happens, but I'm not sure. Because quite honestly, I tend not to use this form very often. I tend to use the canonical form, which I'll show you in a sec. But as long as we're being cute, let me point out that you can also do finds that are compound, right? So find by city and degree expected, which in fact will do the thing that you think. It will actually construct a SQL statement it'll construct a select statement that actually has both of these things in the where clause, and you specify a number of arguments equal to the number of separate attributes. Now, this means that that's right, you cannot have a database attribute name that includes by or and in its names. Yeah, that's tough. Huh? I think there actually is an or. I think you can do find by city or degree expected, and the right thing would happen. But yes, an implication of this, again, it's convention over configuration, right? The convention is thou shalt not have database attributes that have by, and, or in their names delimited by underscores. If you agree to follow that convention, you get this ability to lazily define these dynamic finders for free. And if you don't want to follow the convention, there is a way to override it. You can go read about it in the book. OK. Someone had asked a question before about sorting. This bottom query, which I realize it gets hard to read as you get down the screen. But here's a case where, by the way, when this find by city and degree expected will return the first record that matches all of those criteria. If I say find all by city and degree expected, right, thou shalt not include the word all with underscores in thy attribute names, then I'll actually get a list of all of the records that match those criteria. And I'm further specifying to the database, I want to limit it to the first 30 records, and I want them sorted by last name. So this stuff is actually passed directly to the database, unless the database doesn't happen to support that, in which case it's passed to ActiveRecord, which does it for you on the way out. Right? So in general, and by the way, there is a version of find that says, here's a SQL statement. Don't touch it. Just pass it to the damn database. You can do that too, but for the most part, it doesn't save you anything, and it breaks portability. So don't do that. Find by condition. So this is the more commonly seen form. This is a form in which the first argument to find is either first or all, and then there's an argument conditions, which can take a few different forms. One form of conditions, which is this first line, is essentially the same string that you yourself would type if you were hand creating a SQL select query. So in this case, I'm writing last name like Fox and degree expected greater than blah. What the hell is all this stuff in yellow? Welcome to string interpolation. If you have a double quoted string in Ruby and you have this construct, which is hash and then a pair of braces, everything between the braces is executed as code, and the result is interpolated into the string. So in this case, the thing that's being interpolated is I'm going to take this date string. I'm going to call date.parse, which takes the string and converts it into a date object, right? Because that's the thing that I need to compare against the database. And I'm going to convert that to a formatted string, which in ActiveRecord terminology means the kind of string the database would like to see when you represent a date. So again, using things like toFormattedS makes it database agnostic. If you switch to some weirdo database that marshals its dates differently, the right thing will happen. And as you might imagine, date is a pretty robust library. So date.parse will understand almost anything that is humanly intelligible as a possible date. Here's another way to do it. I can say find all where conditions is, and now I have an array. The first element of an array is a string with a bunch of question marks in it, and the remaining elements of the array are used to interpolate into that string. Why would you use this method? Because this prevents SQL injection attacks. Basically, all of these arguments are going to be sanitized before they get injected into the string. So you'll end up, and by the way, if you're not familiar with SQL injection attacks, A, they're evil. B, don't worry too much about it for the purposes of today. But C, if you use this form, you're essentially immune to most of them. Because it'll make sure that the right sanitization happens before the select is constructed. So, and by the way, it should be clear that I'm going to end up doing the same query in both cases. The second way is just ensures that it's going to be safely constructed. I can also use arbitrary SQL operators. So for example, SQL allows you to say between. I can construct a query for records that have a date between two given dates. Again, if you end up using a database that doesn't support that operator, then you're hosed. Here, I'm also sorting by publication date descending. This, again, if you know SQL, this is a SQLism. If you happen to be using a database implementation that doesn't understand this, you'd be hosed again.
But we could say order by. I mean, we could say order in that top, in the conditions.
No.
You can't say order like you did before, colon order.
Does an ActiveRecord sort it for you?
Yeah, colon order. But if you try to put it in the condition statement, it's generating SQL. So that's the where clause. If the order happens to be right after that, it's fine.
Let me clarify. You're saying, are you asking, can you use colon order hash? Yes, you can. So this is always safe to use in the sense that it's guaranteed not to cause the database to barf. The database may not support order by natively, in which case ActiveRecord, I think, will do it for you. But now, the other thing is you could just pass, like I said, there's a way to pass a fully formed SQL string, and it could include order by blah, blah, blah. But now you really have to make sure that you're using an underlying SQL database that understands order by, or the database itself will barf. And then the exception just gets propagated back up to you, and the find will fail. OK, so caveat programmer, if you care about database portability, try to use the keywords when you can. You can also do a whole bunch of other great stuff. Again, if you're not a SQL weenie, don't worry about this. But if you are a SQL weenie, be advised that you can take locks on the records. You can select something other than the default, which is to return all attributes. You can use, if you select a subset of columns, you can group the result by something. You can load objects as read-only, which means that if you then try to call save on those objects, it will fail. And when Will talks about multiple table models, you can use include. Include is really useful, and I'll give you a preview of it just because you'll get really excited and come back after I'm done confusing you here. But suppose that I've defined a foreign key relationship that's one-to-many. In other words, I have a given table such that I have two tables, and in my second table, there's a subset of rows in my second table share a foreign key to a single object back in my first table. So for example, my first table is professors, my second table is students who are their advisees, and there is a one-to-many relationship from professors to students. If I do a find on the professors table, but I say colon include students, it will basically prefetch from the students table all of the foreign key associations that are related to each one of the found records in the professors table. And honestly, if the reason that you're doing that is because you're then going to take each professor and walk through their students and do some operation, it saves you a hell of a lot to say include, and now ActiveRecord essentially has cached all that stuff for you. Right? By the way, it works without include. If you do a collection of professors and then you individually dereference students without having said include, it'll still work, but it'll take longer because now you're actually doing a separate database join on every single professor, whereas before you got the whole thing in one fell swoop. Yes?
It just returns to enumerable? How does that?
No, it actually just returns the one that you asked for, but the hierarchical association is cached so that when you dereference it, it doesn't have to do a separate query round trip. It's pretty cool. All right. Caveat. There's room for confusion here, so I'm going to eliminate the confusion forthwith. As we've been saying, the result of a find all operation, or in general, any find that isn't limited to a single record, is an enumerable. Recall, or maybe you don't recall because I don't remember if Will went over it or not, enumerable is a module, which means that it is a collection of methods such that if you define each for your class, you get all these other cool methods for free that assume the existence of each. One such method is find, confusingly enough. Right? So the find method of enumerable just says, go through an enumerable collection and return that subset matching some criterion that I specify. Not to be confused with ActiveRecord find. They are different. So sometimes you'll see code that looks confusing because you'll see model.find some stuff for the database, and we'll call the result of that is some collection C. And then downstream you'll see C.find some other stuff. That second find is not an ActiveRecord find. It's this. Right? You're actually calling the find method of enumerable, and that allows you to essentially do an array selection kind of operation. So because I'm sure it's going to come up sometime, I want to make sure to eliminate the confusion. Here's an example of this in action. I first do a student.find, and this is a database operation where I'm selecting for these conditions. Then the result of that, so now I'm going to find all of these students who match that who have palindromic last names. I had to think of something to do, So now I'm going to take students, which is this collection, and I'm going to call findAll, which is an enumerable method that will find all the students for whom this block evaluates to true as S is bound to the students one by one. So anyway, oh, and here's another one. Some lucky student is going to be, the first student whose UCB ID is an odd number and last name is palindromic is the lucky student. So the example is contrived, but hopefully it will serve to avoid confusion. OK, that is an introduction to some of the basic things of ActiveRecord, of which find is by far the coolest. And again, when Will talks about multiple model associations, you'll see just how cool it really is. Let us move on quickly to an overview of ActionView. So you already saw kind of ActionView by example. Basically, it's a system for taking templates and allowing you to use them to render views of the model usually, and then interpolate code into those views that prints out stuff about the model. Just because you can put code into the templates doesn't mean you should. Good programming style suggests that you want to, as much as possible, put that code in the model and the controller, and the views should really have just kind of very terse code snippets, right? So, it might, for example, suppose that in your list view, you want to sort the model and sort the model objects in some non-obvious way. It's better style to put that stuff into the controller so that the controller is going to hand the view an array that's already in the correct order. And then in the view, all you're really doing is showing each element of the array. So what does ActionView provide? It provides this nice templating system. The views from model foo by convention are under app_views foo. It also provides a bunch of helper methods for interacting with models. And these are really cool. We'll see these in a minute. Basically, what it does is it makes it very easy to take a model object and automatically generate HTML elements based on the object attributes. It also makes it very easy, more relevantly, to accept an HTML form input from the user and in a very streamlined manner assign that form submission to the right attributes of a model object. And it provides support for what Will mentioned as dry, called don't repeat yourself. Basically, a problem that you often have in these dynamic content applications is that there are chunks of things that you'd like to render that occur over and over again. For example, you might have noticed, even in our totally trivial student application, that when we create a student, we have this kind of, let's go back here so you can see what it looks like. This is the view for a new student. The view for creating a student, although in this case the creation failed, if we want to show a student. So there's actually, you can see that there's a lot of commonality among the different views. One of the things that ActionView provides is a way to break down views into chunks and make the chunks reusable in a parameterized way so that you don't have to repeat the same code all over the place. And it provides it in at least two ways. One of them, which we saw very briefly before, is the idea of a layout. A layout wraps the real content of a view and captures commonality either at the model level. So we saw, for example, that there was a student level layout that gives the page title student : some action name. And there's also an application level layout, which is above that and logically wraps anything. The other thing it gives you is partials, which is a way to explicitly capture in chunkified form those parts of your views that are likely to be reusable somewhere else. So we'll take a look at that in just a moment. So let's first talk about these helper methods for input and output. We already saw a simple view, which is looking at the, let's find, whoops. This is actually a component of view, and we'll walk through it in just a moment. But you remember that whenever we have %equals, that means run the code and interpolate the output. Whenever we had just plain %, like we had in this list view, this is code that is executed, but the output is not going to be interpolated anywhere, so it's silent. But these form tags that we saw, so here, let's go back to the Mad Libs. There we go. So you'll notice that there's a difference between these two views. When we did the Mad Lib thing before, remember we didn't have any model there. It was just a view and a controller. Here's how we generated some of these tags. We said text field tag. We specified the name of the text field and a default initial value. Whereas here is how we're generating the text fields for editing the students. In this case, it's not text field tag, but just text field. So this is a different method. And what's actually happening here is we're using a helper method that is specifically designed to pull stuff out of models. What we're saying is you're going to be rendering on behalf of a model whose class name is student. And one of the attributes of that model is last name. Therefore, what this means in practice is create a text field that A, will show the default value of this, which is whatever the current value of the attribute is in the model, and B, is set up in such a way that when the user fills in that field and submits the form, the parameter names as unmarshaled into that params hash, which we're going to see again in a moment, are already set up so that you can take that whole thing and wholesale assign it to an object. So this is easier to see than it is for me to explain. So let us actually go and see it. So in the RHTML template, which we just saw, we say text field student last name. If you look at the HTML that's delivered to the browser, and I'll just, to show you that I have nothing up my sleeve, I will show it to you, and then we'll go back to the, OK, so you don't want to read through all this, and I have stylized some of it away. Here's the part you care about, right? This is the result of this, right? So remember, %equals means run some code and interpolate the output. Text field is actually a method that is going to return all this stuff as a string and interpolate it into the view. So we have an input field. The field has an ID. Remember that HTML elements can have IDs. The field has a name. That's kind of weird. The name of the field looks like an array dereference. In a minute, we will see why that is. It looks like a hash dereference, actually. A default size, whatever. A type equals text. Value equals Fox. Now, where the hell did that come from? Well, because the underlying model object for the page that I was looking at came from a student instance object that already had these things filled in, it grabbed the existing value of last name from that student object and suggested as a default value. Again, you can override all that stuff, but by convention, this is what you get. OK, so what happens when we look at the partial? Here is a partial. Whoops, wrong window. So here's a partial. This partial represents that collection of like 3 or 4 fill-in elements that provide the form for editing a student. And the reason that it's pulled out into this separate file is so that we can reuse it in the new view and in the edit view. Right? If you look at when I say student.new, you see this view. If I do student/edit, oops, looks pretty similar. Right? And in fact, it looks pretty similar because this intermediate chunk was used to generate both of them. If we look at the actual actions, here is the edit action. So the edit action doesn't, this is the RHTML template that gets called when the controller is asked to do an edit. There's not really a whole lot here, right? There's a form tag which says when the form is submitted, we're going to call the update controller method. That we've already seen. And by the way, when the form is submitted, you're going to pass, in addition to whatever else is in the form, an additional parameter called ID. And that ID is going to be the ID of the student object. Then render partial form. That's where this comes in. Don't worry about the underscore in front of the file name. It's a convention. But what this is doing is essentially including that file in place. That file makes reference to, all over the place, to this object called student. And it's no coincidence that that's the object name and that this variable is expected to have been set up by the controller. In fact, and then we have the submit tag. And as you can see, looking at peeking under here, the submit tag does indeed have the label edit. Let's compare this to the same thing for the new action. Look how similar they look. Right? In fact, the only thing different is that in the new action, I'm going to point my controller at the create action as opposed to the update action. Makes sense because new assumes that you're adding a new student. Render partial form is exactly the same. The label on the submit tag is different. It's going to be called create rather than edit. But the intermediate stuff that actually does the work is pulled in via the partial. Excuse me. So the difference between these two views in this case is really trivial. And that's by design, right? The key thing is that both of them set up this instance variable called student, or they expect the controller to have set it up. Let's go back to the controller and look at the methods. Here's the new method. So what does the new method do? So if you point your browser at blah, blah, blah /new, the first thing that happens is that an instance variable at the controller level called student is assigned to student.new. In other words, a brand new student object with no attributes filled in. Then it falls through to the new view, which is going to pull in that partial, which will have no default values to display. And if I look at the edit action, def edit, there it is, it also sets up student, right? Again, no accident that they're setting up an instance variable by the same name. It's because that makes it easy to reuse the partial, because the partial is going to refer to that variable by name.
Isn't that second student an enumerable though, since it came from student.find?
Which second student?
The one that the person is looking on right now, the edit student, as opposed to the create student.
But note, very good question. So why isn't, so when I'm assigning to @student, why is @student a single object and not an enumerable? Is that the question? Mm-hmm. The answer is because I'm using the form of find where I'm finding a specific primary key ID. right? And this is a little bit confusing, but remember that the result of find is either an object or an enumerable, depending on how you called it, right? I'm calling it in such a way that the thing that I get back is one object. And in fact, if I call it with an ID of a non-existent student, remember this is scaffolded code, so it's not intended to be production use, then I will get an exception, right? In fact, let's simulate that just so that you can see there's nothing on my sleeve. If I edit a student whose ID number is non-existent, sure enough, I get ActiveRecord, record not found, and that's because I'm using the non-robust form of find, which will throw an exception if this primary key doesn't exist, right? Again, it's acceptable here because this is scaffolded code. You would never deploy this in production unless, you or me. OK, but the important thing is that both of them are setting up an instance variable of the same name. The instance variable names a single object. That object is going to be dereferenced in form.rhtml to create these default fields with their various default values. We're really close to understanding how the magic of validation works, by the way. So stick with me here. OK, one more thing about partials. As you can imagine, a very common idiom is if, in fact, I had called find. So let's look at the list action. Let's get back to John Osterhat's question here. Def list. OK, so here's a case where, well, actually, they're found using the paginate method. Yeah. But paginate will eventually call find somewhere many levels deep. But suffice it to say that in this call, students will be a collection. It'll be an enumerable, not a single thing. That's why it's called students. And the reason is that this is the list action, right? The whole point of the list action is to actually display one line for each record in that table. So as you can imagine, that's a really common pattern where you have a collection of objects and you want to display some summary view of each of those objects. And in fact, if the objects are too long to fit on a line and you want like a little panel for each one, a very common way that you would do it is you would set up a partial to display one object instance. And then inside of a loop, you would say for each one of those objects in the enumerable collection, render that partial with student bound to that object instance. In fact, that pattern is so common that there's a special form of render that captures it, which is I'm going to say render a partial using the local variable student. But the way that I get that local variable is I'm going to iterate through the enumerable collection of students, in turn setting it to each one and then rendering that partial on each. Right? So these two they have the same effect. This one's just quicker to write. Again, you have to be willing to comply with the convention over configuration, have the controller set up the variables that have the right names, and be willing to use the same variable names in your partial as you're seeing in your top-level view. But if you're willing to do those things, it makes it a lot easier. By the way, you can do other stuff with partials too. There's an option that lets you pass a divider, so that if you have a little pane and you have a nice, squiggly line or something divider that you want to space out, you can pass that in. If you want to define additional local variables that are visible in the scope of the partial and have nothing to do with student, there's a way to do that as well. Read the book. OK, so now we know enough to understand all right, well, we'll do it. Let's break validation again. Now we know enough to understand how this happens. You may not realize it, but we actually do. So what's going on here? Whoa. OK. So first, let's start with the visual part. Why is it that even though I change nothing in the views, all of a sudden I have this cool red frame thing, and I've got this field outlined in red? Well, if we take a look at the underlying HTML, I have to scroll. Here we go. So that's the field that was just highlighted in red. And you'll notice in particular that this input, unlike all of the other inputs that are up here before it, this one is wrapped inside of a div, which is basically an HTML element that specifies structure but doesn't carry it doesn't carry semantics of being an inlined element like a list or a table. It's a logical division. And the class of this div is field with errors. So those of you who are already a couple of steps ahead of me will realize that, aha, somewhere there must be a CSS file, cascading style sheet, that declares if something has the class field with errors, then it should be, then it should be displayed with this red frame around it. And in fact, there is. If you look at the general student layout, you'll see that somewhere up here, there it is. So this, again, remember this was generated automatically by the scaffolding. Style sheet link tag says, portably generate a URL that will pull in a style sheet called scaffold.css. And I won't bore you by opening scaffold.css, but you can take it at my word that one of the things it says is something that has the class field with errors should have a red outline around it. So that's where the red outline comes from. And how does the red outline know to be there? Well, remember how the form generates those text fields to begin with, right? We don't actually have HTML markup to indicate the fields. In fact, we're using this helper. Everybody still with me here? The text fields are actually being generated. The HTML that becomes the text field is coming from these calls. So what's happening? It must be the case, right, by deduction, that when I call, when the view is rendering and text field is called with this combination of arguments, somehow it must know that the text field being returned should be wrapped in that div to give it the right attribute so that it'll be rendered differently. How does it know to do that? Well, as it turns out, the way validations are implemented, an ActiveRecord object has an additional set of methods you can call on it. Here we go. So my student object, by virtue of being a descendant of ActiveRecord, actually has this other attribute called errors. Errors is a collection of messages that are generated by the validation code at the time that you try to save the object and the validations fail. And conveniently, there's a helper function called error messages for, which inspects the object and grabs all those error messages. So this answers this part of the question, right? How does this text field method know that it has to wrap one of these fields in a div? Well, it's because it can inspect the error information associated with the student object and figure out that this field had a validation error associated with it. The validation error, of course, comes from the fact that we said validates presence of UCBS ID, and that caused the validation to fail when we tried to save the student object. So we're almost there. The last part is, where does this stuff come from? One error prohibited the student from being saved. Well, that's relatively easy. If we look at the partial that generates that intermediate form, the very first thing in it is a call to error messages for student. That will inspect the student object. If there are error messages in it, it will display them, again, using some CSS magic that will put them in this red box. If there are no error messages associated with the student, it returns the empty string, so no harm done. Right? So again, in the automatically generated scaffold code, this is a helpful way to make sure. And let's look at what has not happened here. What has not happened in this example? Okay? There's no conditional code in any of the views. There's no conflation of logical structure with visual appearance. That's all that's pulled out into the CSS file. There is a method called error messages for that is returned on every single view. But if there are no error messages, then this method call returns an empty string. So that's pretty good. If there are error messages, the HTML that is returned is tagged in such a way that it'll be tied to the CSS file. Right? And again, you can write your own CSS file, and you can change the default tags that are used to create these error messages. But I'm showing you what you get by default. There's no needless repetition. That same template for filling in the student field, because it's captured in this form partial, can be reused in multiple views. There's a layout for all students that captures stuff common to all the student-related views, like the page titles. And although we haven't seen it in this example, but we will see it later, there's a top-level template, application.rhtml. In fact, just for the fun of it, we can put it in. And I'm going to uncomment this stuff at the bottom, which is a copyright UC Regents. And I will now reload my page, which means resending the form, but that's all right. Whoops. Well, I would have thought that would do it, but that's all right. It's one of the few cases in which
You still haven't filled in that ID.
I haven't filled in the what?
You'd fill in the ID, so it wouldn't save when you resubmit it.
Yeah, but I was hoping I would just get, since I stuck this in the bottom of the application level template.
You should hit that.
It seems like that should have worked.
One
oh, well.
second. Okay.
All right. Well, I'm like 2 for 3 in terms of demo, so I'm not going to complain too loudly. So the other way of looking at it, and this gestalt is going to come up again and again, is the world's going declarative, right? The way that we specify how things look on the page was declarative. The way that we specify conditions to validate the data object against was declarative. The way that we specify how to make these little tags, we don't even generate real HTML tags, right? We call methods to generate the tags for us, because then the methods can do various intelligent things depending on attributes of the object on whose behalf they're generating tags. OK, now for the last piece of coolness, ActionController. And this is now the other reason to use these cool tags. So I mentioned briefly that, roughly speaking, each incoming HTTP request means a new controller object is instantiated. Will is going to talk a little bit about routing, which is basically how URLs are mapped to controller names and method names. But for now, we've been seeing the default version of that, which is that the URL has the controller name / the method name, and then any possible arguments appended onto the end of it. We've already seen that parameters can get unmarshaled automatically, whether they're part of the URL or they come in with the form submission, and they get stuck into this params hash. By the way, params is not really a hash. There's various reasons why that's the case. But if you remember duck typing, it doesn't matter, right? We don't care if params is a hash. What we care about is, does it respond to the method double bracket with a subscript that means return an element key to that double bracket? The answer is that it does. And in fact, it also responds to double bracket equals, which is the assignment to a hash method. So don't worry about params not really being a hash. For all practical purposes, it looks, walks, and quacks like a hash. So it is one. We've seen that controller methods set up instance variables. Those instance variables are visible to the view. The controller has access to the model's class methods. And in fact, idiomatically, if we look at the simple scaffolded controller for our students, we will see that a lot of the methods begin by doing a find operation. So for example, in our show, which is a way of saying show me one record, the first thing, in fact, the only thing we see is student.find params ID. Now, what does this mean? Again, tracing back through what we already know, this means that it expects the params array to contain something that says ID. And as it turns out, because of the way routing works, if I just have a single, again, by convention, and you can override this, but a single numeric argument after the controller method gets translated as ID. I think this works, but I don't actually know. Oh, look at that. It does. So that's an explicit way of passing it. So idiomatically, you'll find a lot of these methods. The show method begins with this. The create method doesn't begin with find, because by definition, you're about to create a student. So let's look at what it actually does do, which is pretty interesting. It calls student.new. And remember, I showed that there were 2 or 3 different ways you could call new. One of those ways is you pass a hash to it that gives you all of the key value pairs of how you want to initialize that student object. How cool is this? Somehow we're managing to take just the single element of the params array and pass that thing to student.new, and blammo, the student gets created from the form. OK, so how did that actually work? Let us go back to the student new, and let's take a look at the HTML here. In particular, let us focus our attention on these field names. So here's a field called student square brackets last name. That looks an awful lot like a hash reference, right? In other words, it looks like you have a hash table or an associative array called student, and you're making reference to a key called last name. Again, here's one that looks a lot like student first name, student UCB SID. As it turns out, so that means that we're going to have, I should have typed this out because I can't say it, but here's what it's going to look like. You'll have actually, wait, maybe I do have it on a slide. There we go. I do have it on a slide. So because of the names that those HTML input form elements were given, this is what it ends up this is what the params array ends up looking like, basically, on its way into the controller method. In fact, because I can dereference param student as a hash whose keys are this, it already has the right form to pass to this new call. Does everybody see that? That's almost like sleight of hand, right? The fact that params student, by virtue of the field names being params student last name, student first name, this is itself a hash whose keys are the attributes of the student object. And I can just pass that thing wholesale into the student object, and the right thing happens. Of course, the create method all does some other stuff, right? The create method actually calls save, because remember that creating an object doesn't actually put it in the database. We have to save it for that. And we're calling the version of save that returns true if the object was successfully inserted into the database, and returns false otherwise. So if student.save, we'll talk about the flash in a moment, then good things happen, else bad things happen. So we'll talk about how those good things and bad things work. But that's the other reason to use these kind of built-in, to use the field helpers like text field tag for student, because they give the HTML form elements the correct names such that when you unmarshal the params array, you can just unpack the one object wholesale and send it to the new method. And yes, there's a question.
Is there any interpolation done on those field names, or are they all
Is there any interpolation done on field names? Are you talking about in the HTML code or in the controller? So you mean at the point where I'm grabbing it here in the controller, you're asking if there's any interpolation done on. Oh, that's OK. You're probably also still digesting this, but. On the actual hash values, in other words, the things that I typed onto the form as a user? No. No, in general, no processing is done on the names of the fields. So whatever the field, and because remember that by the time your browser has gotten this page, Rails has lost control of it, right? This browser submission page could have come from anywhere. It just happens to be the case that the names are chosen such that when you unpack them into the params array, they will look correct. But no other processing is done on them. OK. So what else is happening in the controller? I mentioned that by default, once you've entered a controller action, once you fall off the bottom of the action, it will look for a template with a matching name, and it will try to render that. Again, that is the default behavior. And in fact, what's really happening is an implicit call to an actual method, a controller method called render. There are many things that you can do with render besides the default thing that you have seen happening. The most common use of render is rendering an action, which means call this controller action and allow it to fall through. I can also say render the action, allow it to fall through, but don't use any of those default layout templates. Just render the RHTML template bare. I can also just render a piece of text. And when we talk about AJAX, we'll see why there are cases in which you might want to do that. Many other options as well. But the key thing is as follows. In any given controller method, you are allowed one render. Right? This goes with the fact that HTTP means one request, one response. Response is the thing that is being rendered. So if there's a single HTTP request, meaning a single controller method, and it tries to call render more than once, something is wrong. In fact, a runtime exception is thrown if you actually try to call render multiple times. The other thing to keep in mind is that render doesn't terminate the controller method. The way to think about it, if it makes it easier for you, is that render queues up the fact that this rendering is going to occur and be sent back, but it doesn't stop control flow. So you can actually have the word render appear in multiple places as long as there's exactly one code path that will take you through one rendering action. Again, convention over configuration says that if your controller method does not explicitly call render at all, then the implied last statement of every controller method is to render the template whose name matches the action that I'm in, and to do so by using the default layout for the model, if present, and for the application, if present. By the way, if you're a language geek, it might please you to know that the way that layouts actually work is that the layout actually outputs a bunch of stuff, and then it calls yield. So the layout basically acts like an iterator. It outputs a bunch of stuff, and then it will yield to whoever called the layout to produce in place whatever the real content is. That's a language geek thing. So if that doesn't make any sense to you, don't worry about it. But when I saw it, I thought it was pretty cool. We've seen the specific form elements. What else can happen in the controller? Redirect to is an idiom that you see used an awful lot. Redirect to basically is used to allow you to fall through to a different action without first rendering the action that you're in. So when would you want to do something like this? One example that we've seen is the create method. Let us go back to the create method code and see what's going on there. So here we saw we've initialized a new student. We tried to save the new student. If the student saves correctly, don't worry about this flash. We'll explain that in a moment. But what happens on this code path is redirect to action list. Okay, what that means is at this point, I'm not going to do my own rendering. In fact, I'm going to send a redirect back to the browser. And this is the same kind of redirect as when you go to one site and you get flipped to another. The same mechanism is used in HTTP 300. So I'm going to, through a separate round trip to the browser, send the user back to the controller action that corresponds to list. On the other hand, if the student save fails, then I'm going to render a different action. In other words, rather than following through here and rendering my own template, I'm going to do an explicit render, and the action is going to be student.new. I was going to point out a trivia fact about that, but let's not worry about I was going to say that it's rendering the action rather than redirecting to the action, but let's, in the interest of time, not worry about that distinction. So redirect is used in this case even on the success of a create, because you'll notice that there's no create.rhtml view anywhere, right? Which, when you think about it, makes sense because, edit, well, you need to have a view for that because it's got to show you the thing you're editing. List, you certainly need to have a view for that if you're going to list all of the instances of something. But what kind of view corresponds to create? Once you've done the create action, there isn't really anything in particular that it makes sense to display. In fact, an alternative thing we could have done here is we could have redirected to the show action and then shown you the thing that you just created. That would have worked too. But the idiomatic use of redirect to handle this case, in other words, the case where either it doesn't make sense to have a view for this action, so I'm going to send you back to a view that makes some sense in context, or in some cases, if the action fails and you want to send the user back to the same action over again, you can use redirect for that as well. So I point that out because it's an idiom that you see fairly often. And again, this is actually done using the browser round trip mechanism. So your browser will get a response from the initial create action that will say HTTP 302 found. The new URL will point to whatever redirect to said, which is why if we were to successfully create a student, this time I'll actually put in an ID so it doesn't get rejected. If I click the create button, you will notice that I've been redirected back to this list action. Right? That is the result of this redirect to action list. And conversely, if I try to create a student and I deliberately make it fail the validations, sorry, I have to pick on somebody. Oops. Let's make it fail that validation. Right? In this case, I was redirected back to the new action. And you can see that the new template just shows up all over again. And we already walked through how that all works. So that's redirect to. The session hash, and we're getting very close to the end of this session here, so thank you. As we've said, HTTP is stateless, so how do you actually connect a sequence of requests that are originating from the same user as part of an ordered session? The answer is you don't really have to do it. Rails kind of does it for you. Session is a magic persistent hash that's available to the controller, which when I say persistent, it means that its contents are reliably available across HTTP requests that originate from the same user. Cookies are used to figure out whether it's in fact the same user. You don't have to worry about how the cookies are implemented. If you want to stash your own things in the cookie, you can. But a default cookie will allow you to figure out that it's really the same session. Again, session is not really a hash, because if it were, it would have to be either an instance variable, which is destroyed on the next request, because every controller instance corresponds to a new request, or it would have to be a local variable, which is invisible anywhere. So session is actually managed in a different way, but it gives you the illusion of being a persistent hash because it responds to the bracket method. You can stash anything in there that you want. In fact, you can stash arbitrary object graphs in there. It doesn't have to be a printable or a marshallable thing. I wouldn't recommend keeping full-blown objects there. And a common idiom is to put IDs of things in the session and then retrieve the things from the database based on their IDs. Where is the stuff kept that actually identifies the session? In other words, when you dereference things in the session, where does that stuff get stored between requests from the same user? Again, it depends on how you deploy your application. It can be stored in the file system in /temp. You can set up a special table in your database to do session storage. And there's actually an implementation that keeps them in an in-memory redundant hash table that's spread across multiple machines. But from the programmer's point of view, it's a hash that persists across requests. Isn't that neat? So for example, an idiomatic use of the session is I authenticate a user by logging them in. I showed a simple example of that. And if authentication succeeds, I will store a token in the session to indicate that fact. And then when that user comes back, I'll check the session for the presence of that token. And if it's there, then I know the user is good to go. Similarly, the flash. This captures the following common design pattern. I'm about to redirect to some other action, but I want to display a notice to the user because I want to inform them that something happened or went wrong, whatever. But of course, because I'm using redirect to, when the user comes back, that'll be a new controller instance with all new instance variables. So similarly to the session, how do now is when I know the message I want to send, but on the next request from the user is when I actually want to be able to display it. So the flash is another magic quacks like a duck sort of hash. You can set the contents of the flash, and they're going to be passed to the next action invoked by that same user, and then they'll be erased automatically after that. So it basically gives you a way to put things in like, let's finish creating this so-called student. There we go. This student was successfully created. This was actually generated by the controller setting flash notice inside the success clause. Well, this is update, but create does the same thing. There it is. So if student save succeeds, I set flash notice. And if I look at my, my various templates for, oops, do I have a layout for students? There we go. So this is the student's RHTML template. Remember that this, by default, will wrap the templates of any action associated with student. And sure enough, in a green color, I will display the contents of the flash. And if the contents of the flash are empty, then I'll display the empty string in green. Big deal. But that's how you pass messages back and forth. Note that, I'm sorry?
Who clears flash so it only happens once? Is that done automatically?
It's done automatically. And there's actually there's a way to use the flash so that it is shown on this request and then immediately erased before the next one. And in fact, strictly speaking, you could use the session for this and then manually clear out the session yourself, but then you have to keep track of the fact of whether you've used it exactly once and so on. So the underlying machinery is similar, but Flash just captures a very common programming pattern, which is the fact that now is when I know what I want to say, but in terms of program structure, I'm not going to be able to display it until a new controller instance comes. OK, two more things on controllers. Controller predicates. Remember how when we looked at our ActiveRecord models, I can put validations in that express conditions I would like to make sure are true when the model is updated. In a similar way, I can declare conditions that I would like to be true before permitting a particular controller method to be called. So for example, again, looking at my controller, here's an example call to verify. What this says in English is, I'm going to verify that when the actions destroy, create, or update are called, they must only be called from an HTTP post. Now, the reason for this one is that there's kind of a long-standing rule in the web community that if you use get to do an HTTP request, the result of the get should be safe. In other words, gets should not have destructive side effects. So it's OK to use get to list the students, but it is not OK to use get when you're submitting an update to a student because it's destructive. Those of you who are around in the days of early web caching understand where this comes from. So what this says is, in the cases where the method being called is one of those three, verify that the HTTP method is post. If that doesn't occur, automatically do a redirect to this other place. That's pretty good for being declarative. And there's a lot of other stuff you can do. I can say check selectively, so only for certain methods, or I can say except for some other methods. I can check various aspects. For example, I can check if the HTTP request type matches what I want. I can check for the presence of a key in the flash or in the session. So for example, suppose that I have this mechanism where once a user logs in, I put a token in the session hash to indicate the fact that this person has logged in. Rather than having every action in my controller check the session, I simply declare, I could declare a verify or a filter, which I'll show you in a moment, that says, unless this key is present in the session, do a redirect to some page that says, sorry, you have to log in, or its moral equivalent. I can check for a key in params if I'm doing URL obfuscation, so whatever you want. And as far as what happens when the check fails, you can redirect to somewhere else. There's an option called add to flash, which will redirect and also store a helpful message in the flash to tell the user what went wrong. And I already showed you a simple example in our simple controller. In fact, verify is really a special case of a more general usage pattern, which is that of filters, which are basically code blocks that can be run before, after, or both around any controller actions, and they return a Boolean. So for example, I can declare, I can write a method called filter method name, and then I can say, I want to run this as a before filter. By default, it'll apply to all controller actions in whichever file I put this. I can declare a class that implements my filter basically however I want. And just like verify, I can limit the filter to only be invoked for certain controller actions or excluding certain controller actions. I can have multiple filters. So there's calls provided by Rails when I add a new filter to specify whether it should be prepended or appended to the chain of existing filters. And if I subclass my controller, it actually inherits all the filters too. So again, simple use of the filter is I'm checking if my customer is logged in. There's a certain set of actions that you can only do if you're logged in. And if the filter function returns false, filters that return false before the method call will block the method call from ever happening. So if I have a before filter that doesn't return true, the redirect to or whatever alternative action I've specified is what's going to be executed instead of the controller action. So essentially, I'm preventing the running of code unless these invariants have been met. And again, rather than repeating the invariants in n different places, I put them in one place, which is in the declaration of my filters. OK, so, and by the way, I should point out, it begins to take on this weird flavor of aspect-oriented programming, right? Where all of a sudden, before a given piece of code is run, there's 75 callbacks that could happen. I think the only thing to say in defense of that is that given this usage model of I have a web application, it's database backed, I want to do certain kinds of authentication or other filtering before specific methods. I mean, those patterns, there's nothing magic about them, but they're widely used. So yes, it has the flavor of aspect orientation. It's not quite as wild, wild west as pure aspects when you can basically have anything happen anywhere and you have no idea what's going to be called before your function. The callback points are well defined, and they're chosen to capture pretty common usage patterns. So it makes life nicer as a programmer. OK, so here's a wrap-up of this chunk. We saw an introduction to ActiveRecord, which provides a somewhat database-independent object model layered over the relational database systems. As you'll see, it's made much more powerful when you talk about associations among multiple models. We saw an intro to ActionView, which supports the display as well as the input of model objects. And the fact that you can use these layouts and partials prevents you from having to repeat your code in a bunch of places. We've seen how ActionController dispatches actions to the right method. It can manipulate models and set up variables that the views can then use. And also, it gives you a way to declaratively specify some simple preconditions or postconditions, not postconditions, like preconditions and post actions with things like verify and filters. And we saw how the pervasive use of things like CSS combined with the right class and ID attributes put in by these helper methods not only separates visual appearance from structure, but it gives you a way to do fairly sophisticated things like showing these warnings without putting conditional code explicitly anywhere in your views. Pretty neat. So this was 1 hour to say what you could easily spend 8 hours on. I realize there's a lot of it, but once you start programming it, it really starts coming very quickly. Hopefully, you're getting the general idea of it. And I think with that, it is time for questions and then another short break. Or maybe a longer break. I don't know. Are there questions about this stuff? People are too dazed.
We killed them. Oh, no.
Boy, wait till we talk about ActiveRecord associations.
Exactly.
OK, so if there are no questions about this, why don't we take 5 or some number like that, take a small integer, and then reconvene and learn about multiple models.